Hello everyone, I'm Abhijit Purathoki and welcome to my YouTube channel. Today we are going to continue the part on date and calendar method, and this is part 2. So here we will be discussing about the use of that trick. We only discussed what the trick was in the previous video. So in this video we are going to use that trick for finding the day of the week of the dates given here. And I have chosen 4 different dates very randomly, and let's find out the which day of the week was at that time. So first date we have is 1900 February 29. Now we must remember from the trick that first we assign a code for day. So 29, for 29 it is modular divided by 7, and we know the answer here is remainder. So close to 29 there is 28, which is exactly divided by 7. 7 times 4 is 28, and the remainder is 29 minus 28, 1, right? 7 times 4 is 28 and 29 minus 28 is 1. So our first code is A is equal to 1. Now we move into the month, and for that we need to first find out what type of year that is 1900 is, and for finding the type of year we need to divide it by 4 and see if it's exactly divisible or not. But we know that any number can be shown to be shown if it is exactly divisible by 4 or not by only dividing the last two digits by 4. So 00 divided by 4 is exactly divisible. This division is, this gives us a value 0 without any decimal numbers. So exactly divisible means the year is leap year, and for leap year the code B is equal to 0, right? And now we move into the month code, and for leap year we know that February lies in the first group, right? So for the first group in leap year there is a specific code that is 034, and while we go from January to February, February, so the code of February is 3. So this is the code C. Now we move on to the year part. For that we must subtract 1 from 1900. This will give us 1899, right? And then we break this 1899 apart into some century leap years and then some century years and the remaining years. So the century leap year that is closest and just below 1899 is 1600. Now to make it 1800 we have to add 200, 2 century years, 2 centuries plus remaining years is 99. We completely ignore the century leap years, right, because the code for them is 0. And then for 200 we know that for 100 the code is 5, for 200 the code is 3, and for the 300 the code is 1. Here if we want to memorize this easier, we go from 5 to 1. These are all odd numbers. So 5, 3, 1. If we 100 gets the 5, 200 gets 3, and 300 gets 1. So for 200 the code is 3, right? So we have another code D is equal to 3. Now we move on to the remaining years, and for remaining years first we integer divide by 4 to find the number of leap years, right? We divide 99 by 4, integer divide. This gives us 4 times 2 is 8, 1 is remaining, right? 1 9 19, and close to 19, 4 times 4 is 16, and the remainder is 3. So 3 is our remainder, and the integer part is 24. So the number of leap years is 24. Now for code E we need to add I and R, that is number of leap years and remaining years. This will give us 24 plus 99, and this will have 9 4 13, 9 to 11 1 12, 123. So the code for E is 123. We have got all the code. A is equal to 1, B is equal to 0, C is equal to 3, D is equal to 3, and E is equal to 123. So let's add them up. 1 plus 0 plus 3 plus 3 plus 123, 33617 310 2131. 130 is our sum. Now we need to perform modular 7. If we perform modular 7, then we will having the remainder as an answer. So 7, let's find out which number is the closest that is exactly divisible by 7. So 7 times 18 is 7 8 56 6 5 7 1 7 5 126. So if we subtract 126 from 130, then the remainder part is 4. And for 4, this will give us the week of the day of the week. 0 for Sunday. If we go like that, 1 2 3 4, Sunday, Monday, Tuesday, Wednesday, Thursday. So this 1900 February 29 must be what? Thursday. Thursday is our answer, right? This all trick, and this gave us to Thursday. So 1900 February 29 is Thursday. Now let's move on to the next question, B. And I chose it specifically as February 29 because since it's a leap year, right, the February must have 29 days, and I wanted to find out what that day could be, and we did find out, right, and the answer is Thursday. So let's move on to the next question, 1949 October 7. October 7. Now first modular divide the day of the month by 7. 7 mod 7. Since it's exactly divisible by 7, this will give us answer 0. So the first code we have is 0. And for month, let's find out the type of year, right? For finding the type of year, take last 2 digits and divide by 4. If it's exactly divisible, then it's a leap year. If not, then it's general year, right? 4 times 1 is 4 and 9 remains. 4 times 2 is 8 and the remainder is, we can see, 1. So not exactly divisible, right? So this is a general year, and for general year we have code -1. So this is the code for B, -1. And since it's a general year, then we need to find the code for October, right? We know that October is the 10th month, and we can see 3, we have groups of 3, right? 3 3 6 3 9. So the first member of the last group is our answer. But if you find that difficult, last group is, we know that 1 4 6, right? So the first member of that group is 1, and the code for October will be 1. But if we find that is difficult, then we can say for general year the first code is 1 4 4 12 squared, then 5 squared 0 2 5, then 6 squared 0 3 6, and the last is 12 squared plus 2, or 144 plus 2, that is 146. Now let's find out the code for October, right? January, February, March, April, May, June, July, August, September, October. So the code for our month is 1. We can see C is equal to 1. Now let's move on to the year part. We have 1949. First we must subtract 1 from this year, and this will give us 1948, right? Now we expand this number into some leap century year plus some century years, and then the remaining years. So the closest leap century year that is just below 1900 is 1600, and from making 1600 to 1900 we have to add 300 more, plus the remaining years is 48. We can ignore this century leap years. For 300 we know that the code is 1, so our code for D is 1. And for finding the last code, that for the remaining years, we need to find how many leap years are there, and for that we can do 4. 48 divided by 4. This is exactly divisible by 4. It will have the value 12. So the number of leap years here is 12, right? Now we must add I and R for the code E, and this will give us 12 plus 48. 8 to 10 0 4 1 5 1 6 60. So the code for E is 60. Now let's add them up. A is 0, B is -1, C is 1, D is 1, and the E is 60, right? -1 plus 1 cancels, and 60 plus 1 is 61. Let's perform modular division by 7. And we know that 7 times 8 is 56, which is closest and a little bit lower than 61. 61 minus 56 gives us 5. So we know that the number this will give us the day of the week, right? So 0 for Sunday, 1 Monday, 2, 3, 4, 5 will give us Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So this 1949 October 7 must be Friday. Alright, now let's move on to the next question. That's 1999 December 25. We have 1999 December 25. Again for this, let's go for the day of the month. 25 mod 7. We know that 7 times 3 is 21. So 25 minus 21 will give us 4. Our first code is 4, right? And then for the month, we need to find out if the year is leap year or general year, right? And for that, we take the last 2 digits from the year 99 and divide by 4. If it's exactly divisible, then it's a leap year. If it's not, then it's a general year. Since it's not exactly divisible by 4, we say it's a general year. And for general year, we have the code -1. That is B is equal to -1 is our next code. And for now, for assigning the code of the December month, since it's a general year, we know that the even in both the general years and leap years, the last code is 146, right? It is easy to find out. So the last code belongs to the last member of this group belongs to the December. So our code for December will be C is equal to 6. Now for the next one, we need to subtract 1 from 1999, and this will give us 1998. And again, we need to break it apart into century, leap years, and century years, and then remaining years, right? The closest and the lower, a little bit lower century years is 1600. Plus, for making it 1900, we have to add 300. Plus, the remaining years is 98. We can totally ignore that for. And for 300, we again know that 5, 3, 1, 100, 200, 300, right? So the code for 300 is 1. And now for 98, since it's the remaining years, we first divide it by 4, right? Integer divide by 4. And this will give us 4 times 2 is 8. Remains 1. 1, 8, 18. 4, 4, 16. Remains 2. Now since 2 is not divisible by 4, then the integer part that we have here is 24. This is equal to I. Now the last code is obtained by adding I and R. Here I is 24 plus R is 98, and this will give us 8, 4, 12, 2, 9, 2, 11, 1, 12, 122. So we have all the codes, all the necessary codes, right? A is 4, B is -1, C is 6, plus D is 1, and E is 122. -1 plus 1 cancels out, and 6 for 10, 10 plus 122 gives us 132. Now we perform modular division by 7. This will give us 7 times 1 is 7, right? The remainder is 6, and 62. 7 is 56, right? 62 minus 56 will give us the remainder 6, right? 7 times 1 is 7, and the remainder is 6. 6 to 62. 7 times 8 is 56, and 62 minus 56 is remainder is 6. And we know that we go from 0 to 6 from Sunday to Saturday, so 6 must be Saturday. So 1999 December 25 must be Saturday. Now at last we have got 2016 May 16, and I will do that without explaining. So watch for yourself for the steps that I take, and reflect on that. We have 2016 May 16, right? Seven times 3 is 2. So 2016 May 16 must be Monday. Now we know here that there is no century years, so no code for D, and we don't have to write like exactly divisible 16 mod 7. We can we have to practice so much that we need to instantly figure out what the code A is, right? So this is it. And if you are not sure about whether the trick is right or wrong, then you can simply check this on any Android calendar, or any calendar that you may find on Google, by simply jumping to these dates, right? So if you liked my video, and if you liked my trick, and if you like the video that I made on its application, then please give thumbs up. And if you haven't subscribed my channel, then please subscribe it. Press the bell notification icon also for getting updated notifications about upcoming videos. And please do comment me if you have any advices or any questions or suggestions. So thank you so much for watching.